Welcome to lesson 6 of the CSEC Physics Syllabus at Edu Solutions Institute. So today we're looking at types of forces. Now, forces are any action that causes an object to change either its shape, its size, its direction, or its general motion. So therefore, if we do something to an object and it changes its size, what we have done is called a force. Right? If it changes its shape, it's a force that causes an object to change shape. Now, in general terms, we have a lot of forces that exist, but these are the forces that we're going to look into in our lessons today. So the first one is called the elastic force. Now, the elastic force is a force that causes object to return to its normal position when it is either stretched or compressed. So example would be like springs. So when you extend a spring and you release it, the spring comes back to its normal position, or a rubber band. Or if you compress the spring, meaning you push it closer together, when you release it, it flies or it returns to its original position. The force that's responsible for doing that is called your elastic force. The tension. Now your tension force is now in like strings or ropes. Because on a normal string, without anything applied to it, there is no stiffness in the string. But as soon as you apply, if you stretch the string, even though it's not going to be stretched as an elastic object will, it gets stiffer. The reason why it gets stiff is because when there is an applied force that's probably pulling it down, there is a tension force pulling the string upwards. And that tension force is created so it doesn't cause the string to break. Now, if you apply a good force to it that you can't, the tension force cannot balance off, then the string will break. So therefore, the tension force of a specific string is 10 newtons, and you apply a 20 newton force to that string, then the string will break because it only can create a 10 newton tension force to balance off any force that is applied to it. So therefore, a tension force is what we call a responding force. So it responds because you applied something to it, and it balances off that force. If it can't balance the force, then the string will break. Next is called frictional force. Now this one is very simple. Frictional force is called an opposing force. It opposes the motion of objects, but the only way it can create it is when two things are rubbing. So if you rub your hands together, when you rub your hands forward, then that means your frictional force is opposing that forward motion, so your frictional force is coming back. When you're rubbing your hands backwards, your frictional force is opposing that, so it's pushing forward. So therefore, frictional force is generated when two objects are rubbing against each other. So once they're touching and moving, then we have frictional force. A common frictional force is what we call air resistance. And by the name suggests is any object that's moving in the air particles will rub on the object, and that will cause or generate a frictional force called air resistance. So if the object is going forward, the air resistance, the air particles are dragging back the object in the opposite direction. Our next force is our weight. And weight is what we classify under gravitational force. Now, gravitational force is generated when we have two masses that are attracted to each other. So when you hear gravity on Earth, what it actually is the force of attraction between Earth and the Sun. Because the Sun is at the center of our galaxy, right? So therefore, all our planets rotate around the Sun due to the gravitational force. We are pulled towards the Sun, so therefore Earth is attracted towards the Sun, and that generates gravitational force. Now, the effect that that force has on objects on Earth due to the presence of mass is what we call the weight of the object. So therefore, if we're on Earth, we will have a specific weight because there's a gravitational force there. But when we go in space, you see those movies where the astronauts are floating in the air, seem to be weightless. And that's because the gravitational force in space is much smaller than it is on Earth. So therefore, gravity on Earth pulls things towards the center of the Earth because the Earth is being attracted from its center to the center of the Sun. So all force on Earth, based on gravity, will be pushing down to the center of the Earth. We have our normal force. Now our normal force is a 90-degree force towards a surface. And what that means is, if I put my hand on the wall, then the wall is generating that same force back on my hand at a 90 degree to the surface. So therefore, applied force generates a normal force on the wall coming in this way. If I am standing on the ground, then the ground will put a normal force back up, right up, at the same size as the weight that I'm pushing down on the ground. Now, if I'm supposed to be sinking below the surface of where I'm standing, then that means my weight is more than what my normal force can sustain. So therefore, the normal force is not able to balance off my weight, hence I'll be sinking down. And then we look at the magnetic force. This one is very unique, it's very popular. This is the attraction or repulsion between magnetic objects. So therefore, if we have one magnet here, one here, we put them close together, you feel some pushing force. So if they push apart, or they will pull together. So that force is called a magnetic force. Then we look at an electrostatic, which means these deal with charges now. So charges between themselves will do the same thing, where they will be attracted to each other, or they will be repelled from each other. So therefore, a simple demonstration we normally use is to take a pen or any glass or perspex material, you rub it, or you can use pipe, or a balloon. So you rub it onto a cloth object, you can rub it on your clothes, and then you can put it close to your hair, and you notice your hair particles stand up due to the presence of the balloon or the pen. And what that is that when you're rubbing it on your body, you're creating charges to be accumulated on the object. And then when you put it close to your hair, it's going to attract the opposite charge in your hair particle, in your hair, and hence you get that attraction, right? So that's what we call electrostatic, because the static part here tells us that the charges are not moving, but they generate that force that we feel, the attractive or the repulsive force. Now finally, the type of force we look at is called the buoyancy force or the upthrust force. And this is where in fluids, that's either in air or in liquids, when an object is placed in it, there is a force that's tend to want to push it up. Right? So therefore, when we put something in the water, the water particles are actually generating a force upwards to try to keep the object on top of the water. That force is called the buoyancy force. And that's the force that's needed to get objects to float. Now, objects that do not float mean that their weight that's going down is greater than the buoyancy force that the liquid can produce, and hence it will sink. Now, what are some things that we can do to improve on the floating abilities of objects? Basic one, because ships are big objects, but yet they can float in water. Some ships are made with basically in their bottom part that is under the water, they are made or filled up with substances or gases that are way lighter than water. So it actually tends to trick the water to say, hey, I'm very light. And hence the thrust can actually balance off what it's feeling. And hence the boat can float. So these are popular forces that we have in physics that we will use quite a lot through the course of the CSEC syllabus. Right? So please note all of them and know what they are defined as. As we go along, we will do calculations involved with some of these same forces. So thank you for watching, and I'll see you next week where we continue to learn about the CSEC physics syllabus. Thank you.